Okay, hello everyone in a new video. So we have reached part 4 of chapter 6, which is the chapter of center of mass for grade 11 students. So now we have reached section number 3, which is given by the force. And let me start by defining the force. And let me say, or let me write the force as a mechanical action exerted by a body on another body, say for example, or another. And the important thing is that the force is represented by a vector F. So the definition of the force is given by the mechanical action exerted by a body on another, but the more important one, which is the mathematical definition, is given by the force is represented by a vector F. So we know that the properties of a force are given by, so let me write down properties of a force, or the characteristics of a force. And they are given by the Pilldon. The first one is given by the point of application. The line of action, which is horizontal, vertical, or oblique. The direction. And the magnitude. Now in this case we are interested in representing these properties using the vector formulation. Okay, so if you consider the document on the right, we have a force vector F lying in the xy plane, making an angle alpha with the x-axis and an angle beta with the y-axis. So in this case the force F can be written as Fx, the unit vector I. So the unit vector I represents the x-axis plus Fy multiplied by the unit vector J. So we are interested in the point of application, line of action, and the direction and the magnitude of this force. So this is said to be the vector notation of a force. And this holds for any vector, not only for the force vector. For example, the velocity can be given as Vxi plus Vyj. The acceleration vector can be given as Axi plus Ayj. The position vector R is given by Rxi plus Ryj, but usually this vector is denoted by R is equal to Xi plus Yj for short. Okay. Now, referring to this document, we can see that the point of application in this case is the origin, so we can see the origin. Now, the line of action and the direction are represented in the unit vectors I and j. Now, the magnitude of this force is given by F is equal to square root of Fx square plus Fy square. So the magnitude of any force or any vector, we just simply drop down the vector, and the magnitude F is given by the square root of Fx square plus Fy square, which is the magnitude of its component. Now, given the angle alpha and beta, we are interested in determining Fx and Fy. So let me say that Fx is the x component of f along the x-axis, or another way, it is the projection of f along the x-axis, whereas fy is the y component of f along the y-axis, or simply it is the projection of f along the y-axis. Now in this part, or in this section, we are interested in learning how do we determine fx and fy, the projections of the force vector f in an xy plane. So let me make here some space, or let me say so in order to determine, so let's first determine fx. So in order to determine fx, we need to take several stuff into consideration. So it consists of three factors. Now the first one is given by either plus or minus, and this depends on whether fx is pointing in the same direction of the x-axis. Notice that in this case fx is pointing in the same direction of the x-axis, so it's positive. Now if fx is pointing, or the vector f is pointing in a direction opposite to that of the x-axis, then here we will place a minus sign. Then we will place the magnitude of the force f, which is f, and then we multiply the third factor is the cosine of the angle between the x-axis and the force f. In this case, this angle is given by alpha, so fx is given by f cosine alpha. Now if we need to determine the projection of the force y on the x-axis, then we have to place the three factors. So the first one corresponds to either plus or minus, depends on whether the force f is pointing in the same direction or in an opposite direction to the y-axis. Notice that it's pointing in the same direction, so this is a plus. Now the magnitude, the second factor is the magnitude. So the magnitude of the force f, we simply drop down the vector, it's given by f, multiplied by cosine of the angle between the force f and the y-axis, which is given by the angle beta. So in this case, this is equal to f cosine beta. Then in this case, the force f, which is given by fxi plus fyj, this is equal to f cosine alpha plus f cosine beta j. Then in this case, f vector is equal to f cosine alpha I plus f cosine beta j, in which alpha and beta are angles. Okay, so this is it for the vector projection. Now let's solve some exercises as a direct application. So this example involves no numerical value. Now let's consider exercise number 7. They are telling me each of documents 1, 2, and 3 represent a force F in a space reference system OIJ. Determine the projection of F along the x-axis and the y-axis, then write F in the vector notation. Notice that the vector F, because it's lying in the xy plane, it can always be represented as Fxi plus Fyj. Now starting by document 1, so this is document 1 and this is the force vector. So let's start by Fx. So always the projection consists of three factors: plus or minus sine, the magnitude, and cosine of the angle. So notice that the force F is pointing in the same direction of the x-axis, so it's plus multiplied by the magnitude, which is F, multiplied by the cosine of the angle between F and the x-axis, which is 60 degrees. So this is equal to 200 multiplied by cosine 60. Now plugging this on the calculator and making sure that the calculator is in the degrees mode. So cosine 60 multiplied by 200. Cosine 60 is equal to half. So this is simply given by 100. Since F is expressed in newtons, then the value of Fx will be in newtons. Then Fx is equal to 100 in newtons. And here, let me say that cosine and sine have no units. So the unit of the cosine is equal to 1 and the unit of the sine is equal to 1. So here for sure we must have an angle, say for example alpha or theta. So the cosine and the sine, the units are given by 1. So if the unit of cosine is 1 and the unit of F is in newtons, then Fx will be expressed in newtons. Now as for Fy, notice that F is pointing in the same direction of the y-axis, so it's positive, times the magnitude, which is F, multiplied by cosine of the angle, which is between the F and the y-axis, which is 30. Now this is equal to 200. The magnitude of F is 200. Multiplied by cosine 30. Cosine 30 is given by radical 3 over 2. Plugging this on the calculator, then the y component, the magnitude of the y component is given by 173.21 in newtons. So Fy in this case is equal to 173.21 in newtons. Now after we have determined the x and the y component of the force F, we need to write then F in the vector notation. Then F in the vector notation is the x component, which is 100, multiplied by the unit vector I, plus the y component, which is 173.21, multiplied by the j component, or the j vector. Okay, so this is the vector notation of the vector F. So notice that in this document the magnitude of F is given in addition to the line of action and the direction. So all the properties, the point of application, the line of action, the direction of and the magnitude of the force F are given. So whenever these properties are given and a reference system is chosen, we can write F simply in the vector notation. Now here, so how do we suppose that we don't know the magnitude of the force F and we are interested in determining the magnitude? So we drop down the vector F, and this is given by square root of Fx square plus Fy square. So this is equal to the square root of 100 to the power 2 plus 173.21 to the power 2, and you can check that the value of this answer indeed is given by 200 in newtons, okay, which is given by this one. Now as for document 2, let's start by the x component. So notice that the force F is pointing in the same direction of the x-axis, so it's positive, multiplied by the magnitude of F times the cosine of the angle. The angle between the force F and the x-axis is given by 45. Now the value of F is given by 75. The value of cosine 45 is given by radical 2 over 2. So plugging this on the calculator, then it's given by 53.03. Since F is expressed in newtons and the cosine is unitless, so the value of Fx is in newtons. Now as for Fy, Now notice that the force F is pointing in a negative direction with respect to the y-axis, so it's a minus sign, multiplied by the magnitude, which is F, times the cosine of the angle between the force F and the y-axis, which is 45 degrees. So this is equal to minus 75 times radical 2 over 2, which is equal to minus 53.03 newtons. And now the force vector F in the vector notation is given by F is equal to 53.03 multiplied by the unit vector I minus 53.03 multiplied by the unit vector J. We don't forget vectors. Whenever vectors exist on the left, vectors must exist on the right, because this is a vector definition. Now similarly here, because now we know the force F in the vector notation, if you are interested in determining the magnitude, we drop down the vector, and this is given by Fx square plus Fy square. If we plug these values here, we can check that the value of F indeed is given by 75 newtons. Now in document 3, let's start by determining Fx, the projection of F on the x-axis or the x component of the force F. So notice that this force is pointing in the negative direction of the x-axis, so it's minus, multiplied by its magnitude, which is F, multiplied by the cosine of the angle between F and the x-axis, which is given by 30 degrees, which is equal to minus 120 times cosine 30, which is half, which is given by radical 3 over 2. Now plugging this on the calculator, then the value of Fx is given minus 103.92. Always all quantities in physics must have unit. The unit of F is in newtons, and this is unitless, so the unit of Fx is in newtons. Then Fx is equal to minus 103.92 newtons. As for Fy, so notice that in this case the force F is pointing in the same direction of y, so it's plus. The magnitude of F is F times the cosine of the angle between the force F and the y-axis, which is given by 60 degrees. So it's convenient to write here degrees. Now the value of F is given by 120 multiplied by cosine 60. The value of cosine 60 is given by half, so this is equal to 60 newtons for the same reason. So Fy is equal to 60 newtons. Now in this case the force vector F can be written as minus 130.92 I plus 60, the y component, multiplied by the unit vector J. So this is it for exercise number 7. Now in exercise number 8, they are telling me each of documents 1, 2, and 3 represent a force F in a space reference system Yj. Determine in terms of F and theta the projection of F along the x-axis and the y-axis, then write F in the vector notation. So because they are telling me determine in terms of F and theta, so the final answer must be just function of F and theta, okay? Now the force vector F in general can be decomposed along the x-axis and the y-axis as follows. So Fx is equal to F is equal to Fx multiplied by the unit vector I plus Fy multiplied by the unit vector J. Now let's start by document 1. So before we start projecting, so notice that the force F is making an angle theta with the x-axis. Since these two angles are complementary, which means they add up to 90 degrees, so this angle is given by pi by 2 minus theta. Now let's start by Fx. Notice that the force F is pointing in the same direction of the x-axis, so it's positive, multiplied by its magnitude, which is F, by dropping down the vector, multiplied by the cosine of the angle between F and the x-axis, which is cosine theta. So indeed the answer is in terms of F and cosine theta. Now as for Fy, so notice that f is pointing in the same direction of the y-axis, so it's positive, multiplied by its magnitude, which is f, multiplied by the cosine of the angle between f and the y-axis, which is cosine of pi by 2 minus theta. Now the first relation that you are interested in is that cosine of pi by 2 minus theta is equal to sine theta. And the second one is that sine of pi by 2 minus theta is equal to cosine theta. So in this case, cosine pi by 2 minus theta is equal to sine theta. So this is equal to f sine theta. Now in terms of the vector notation, the vector f can be written as the x component multiplied by the unit vector I and the y component multiplied by the unit vector j. And here let me do the following. So if you are interested in determining the magnitude, so we drop down the vector, then f is equal to square root of fx squared plus fy squared. Now the x component is given by f cosine theta, so f cosine theta to the power 2 plus f sine theta to the power 2, which is equal to square root of, if we take f squared as a common factor, then we have cosine squared theta plus sine squared theta, and this is equal to 1, which is equal to square root of f squared, which is equal to simply plus or minus f, and we are always interested in the positive solution, so indeed the magnitude of f is f. Now as for document 2, then fx is equal to, notice that f is pointing in the negative direction of the x-axis, so it's minus, multiplied by its magnitude, which is f, times the cosine of the angle between the x-axis and the force f. So if this is theta, then this is pi by 2 minus theta. So this is the angle between f and the x-axis, so cosine pi by 2 minus theta. And according to this relation, this is equal to minus f sine theta. Now as for Fy, f is pointing in the negative direction of the y-axis, so it's minus, multiplied by its magnitude, which is f, times cosine theta. Theta is the angle between f and the x and the y-axis, because we are projecting along the y. So this is simply minus f cosine theta. Now in the vector notation, f is given by minus f sine theta multiplied by the unit vector I, and the y component multiplied by the unit vector j, and you can check that the magnitude of f indeed is equal to f. So depending on the angle theta that we define, the vector notation of the force f changes. Now as for document 3, so fx is equal to either plus or minus sign, depending whether f is pointing in the same or opposite direction. It's pointing in the same direction, so it's plus, multiplied by the magnitude, which is f, times cosine of the angle between the x-axis and the force f, so this is pi by 2 minus theta. Cosine pi by 2 minus theta, so this is equal to f sine theta. Now as for Fy, notice that the force f is pointing in the negative direction with respect to the y-axis, so it's minus f, and the angle between the force f and the y-axis is theta, so cosine theta. Now in this case, f is equal to f sine theta multiplied by the unit vector I minus f cosine theta multiplied by the unit vector j. Now as for exercise number 9, each of documents 1, 2, and 3 represent a force f in a space reference system yj. Determine the projection of f along the x-axis and the y-axis, then write f in the vector notation. Now this exercise represents a particular case, and not unlike the other exercises, in which the force f is completely parallel to the one of the axes. So whenever we say it's parallel to one of the axes, so it's completely lying along this axis. So notice that in this case, the force F is parallel to the x-axis, the force F is parallel to the y-axis, and the force F here is parallel to the x-axis. We know that the force F is given by Fxi plus fyj. In each of these documents we need to determine fx and fy, then we will give the vector notation. Let's start by document number 1. Now as for document number 1, fx can be determined by two different methods. Let me introduce the one that let me use the one that we have used previously, and then I will introduce the new one. So since f is pointing in the same direction of the x-axis, so it's plus, times the magnitude times cosine of the angle between f and the x-axis. So because f and the x-axis are parallel to each other, so the angle is 0, and cosine of 0 is 1, so this is simply plus f. Now as for fy, so independent of the sign and of the magnitude, notice that the angle between the force F and the y-axis is pi by 2, so it's cosine pi by 2, and cosine pi by 2 is given by 0, so this is 0. So this is the method that we are using, but in case of if the force is parallel to the one of the axes, there is another easier way to determine the projections. So notice that in this case the force F completely lies on the x-axis and it's the same direction, so it's plus F. Okay, and in this case Fy will be simply 0. So in case the force F lies along one of the axes, so we will place a plus or a minus sign depending whether it's pointing in the same or an opposite direction, and we will directly place the magnitude. As for the other axis, it will be directly 0. So in this case, f is given by fi plus 0j, which is simply equal to fi. So the vector notation is given by f multiplied by the unit vector I. Now as for document 2, so notice that it's completely lying on the y-axis, so fx is 0. As for fy, it's simply the magnitude f up to a plus or a minus sign. Notice that it's pointing in the negative direction, so it's minus f. Then f is given by 0i minus fj, which is equal to minus fj. So in this case, f is equal to minus fj. Because in a vector definition, vectors must exist on the left and on the right, and the same goes here. Now as for document 3, now we are interested in determining fx and fy, then writing the vector notation. So notice that it completely lies on the x-axis, so fy is 0. Then fx is equal to f up to a plus or minus sign. Notice that it's pointing in the negative direction, so it's minus. And here the values are given, so we can directly say that this is equal to so 40 newtons, so 40i, so F is equal to 40i. So this is equal to minus 35 newtons. So then this is equal to minus 50 newtons. And in the vector notation, F is given by fxi plus fyj. Then this is equal to 0 minus 50i. So in the vector notation, F is equal to minus 50i. And in case we are interested in determining the magnitude, we drop down the vector. F is given by square root of fx squared plus fy squared. In this case, the y component is 0, so it's simply given by fx, because the square root will cancel the radical, which is 40. Okay, so Whenever, let me say the following note, whenever F, i.e. the force, lies along one axis, which means consists of one component, then its magnitude is equal to the absolute value of its component. So in this case, now if you consider the first force, which is given by F is equal to 40I, so without using the rule of the magnitude, which is given by F is equal to square root of Fx square plus Fy square, the magnitude of F is directly given the absolute value of this number, which is given by 40 newtons. Now in case of F is equal to minus 35J, because it consists of one component or it lies along one axis, then F is simply given by the absolute value of this number, which is given by 35 newtons. Now as for F, which is equal to minus 50I, so because this force consists of one component, then the magnitude is given by simply the absolute value of this number, which is given by 50 newtons. So that's it for me in this video, guys. In the next part, we'll complete solving exercises on the projection of a force.